Let's go to page 404 and let's start with number 19. Here, the number 19, you have the point 0, 0, and the midpoint is 3, 5, and you're looking for the point Q. Okay. Okay, so this is the midpoint, so this came from the average of the two. Okay, so basically what you have is you got 0 plus x divided by 2 will give you equal to 3. Okay, so again, you average this, you get a middle point. Same thing over here, you're going to get 0 plus y divided by 2, and the average will give you the 5. Okay, then you cross multiply, so x equal to 6. You cross multiply y equal to 10. So the point Q is going to be at 6, 10. Now this is a coordinate, so make sure you put in the parentheses. Okay, next one. The point P is a negative 4, 0, and the midpoint is at 3, 3, and you're looking for Q. Okay, so again, the midpoint came from averaging the P and the Q. So you just use the formula, right? So when you average, you got negative 4 plus x, right? You add, you divide by 2, and this gives you the midpoint. Same thing for the y. You got 0 plus y divided by 2, this will give you the 3. So cross multiply, you got negative 4 plus x equal to 6, and you plus 4 on each side. So you got x equal to 10. Over here, cross multiply, y equal to 6. So the point Q is going to be at 10, 6. Okay. So this kind of, in a way, is a little bit backward. Okay. Before you have 2 points, you average to get that, but now they give you these 2 points. But you just apply the same formula. Okay, let's go to the next one. Okay, number 23. The point P is at H and K, and the midpoint is 0, 0, and you're looking for Q. Okay. So again, you just apply the midpoint formula. So you have to add, divide by 2 to get that, right? So you got h, so plus x divided by 2. Again, you add these two together, divide by 2, and this will equal to the midpoint. Same thing for the y. You got k plus y divided by 2, right? You add, divide by 2 to find the average, and this will equal to the midpoint. Midpoint is your average. Okay, so you cross multiply. And then you solve for x or minus h on both sides. So x equal to negative h. Over here, cross multiply, you got k plus y equal to 0, minus k on each side. So you got y equal to negative k. So your q would be negative h, negative k. Okay, next, let's go to number 25. Okay, so for this one, you probably have a probably good idea to go and plot the 3 points. So let's go and get a graph paper. Okay, so number 25. Okay, A is negative 2, positive 2. So negative 2, positive 2. So this is A, negative 2, positive 2. And B is 2, 1. And C is 1, negative 3. Okay, so these 3 points are vertices. Okay, so now it says, so vertices ABCs of a triangle are given. For each triangle, determine A, where is isosceles, B, where is a right triangle. If it's a right triangle, find its area. Okay, to find if it's isosceles, we need to find out if the sides are the same. Okay, so that's going to find each length. Just from the graph, you can see that this and this are isosceles. So let's go and find AB. So AB, you have to use these 2 points. so equal to square root of, okay, so you have to use the distance formula, so you're going to get 2 minus, so x2 minus x1 square, okay, plus the y2 minus y1 square, so square of, so length of AB will equal to, okay, so this will give you 4, 4 squared is 16, and this is negative 1 squared will give you 1, so AB equal to square root of 17. So this is square root of 17, okay? Now next, let's go and find the BC. So I'm going to find BC. So same thing. So I'm going to get x2. Now usually you want to use a point to the right. The one that's more to the right, use as a y2. Use as a point 2. That way you can avoid a lot of negatives. So you're going to get 2 minus 1 square, right? x2 minus x1 plus y2 minus y1. Okay. So BC equal to square root of 1 squared is 1. Okay. This will give you 4. 4 squared is 16. So BC equal to square root of 17. Okay. So this is also square root of 17. Okay. Now I'm going to look for AC. Okay. You have to look for all three lengths. So you can square root of, so x2 minus x1 plus y2 minus y2 minus y1. Okay. Okay, so length of AC equal to, this is 3, 3 square is 9. This would be negative 5, negative 5 square would be 25. So AC equal to square root of 34. Okay? Okay. So now let's go and answer the question. So A, okay, whether it's isosceles or not, okay, and so A is yes, it's isosceles. Because this side is, so isosceles means two legs are equal, so yes, it's isosceles. Okay. Now B, to find out whether it's a right triangle or not, then you have to do the A squared plus B squared equal to C squared. See if that's a true. Okay. So you're going to have the A squared plus B squared. You want to see if it's equal to C squared. Okay. You want to check. See, right now you don't know, right? Okay. So you got square root of 17 square plus square root of 17 square, question mark. Again, right now you don't know if it's true or not, right? Equal to square root of 34 square. So you're going to get 17 plus 17 equal to 34. So yes. So part B, yes, it's a right triangle. Okay. So it's an isosceles, but it's also a right triangle, and right triangle is right over here. Okay. Now part C, okay, it doesn't say C, but part C, okay, to find the area, if it's a right triangle, you have to find the area. So if you turn it sideways, right here is your right angle, okay, so area is equal to 1/2 base times height. So area equal to 1/2 base, it would be square root of 17. The height is square root of 17, okay, so area equal to 17 over 2. Now, usually, actually, instead of using A for area, because A is used for a lot of stuff, so probably better to use K, okay? Because K is not used for other things. So normally, you know, A is for like angle A and a lot of stuff. So let's use K for area, okay? So area would be 17 over 2, okay? So again, to find all these, you have to get all three sides, okay? Okay, let's go to the next one. Okay, so again, let's go and sketch it out to visualize. See, when you sketch out your triangle, it's easier to visualize. It helps you to able to think. Okay. Okay, so 5, negative 4, So point A is 5 comma negative 4. Okay. B is negative 3, 4. And C is negative 2, negative 3. Now also a quick way of doing it, since you graph it out, you can just use the Pythagorean theorem. So see over here, so when you graph this out, notice that if you were to draw your triangle, okay, notice if you were to draw your triangle, see that's one on this side, so it would be 1, so you square that, you get 1, and this is 1, 2, 3, 4, square it, you get 16, and you add, that's how you get square root of 17, see that? So if you just draw your triangle, it's a lot easier. So you got 1, 2, 3, so that's 9, right? So you square that, 1, 2, 3, 4, 5, 25, right? 9 plus 25 give you 34, see that? And the same thing on this side. So if you were to draw it out, that will save you a lot of time doing these. They're the same thing. This and these are the same thing, okay? Okay. So you draw it out, it's much quicker, especially if you graph it out already, okay? Okay. Okay, so we're going to do the same thing over here. So if you were to do this, like what we did earlier, okay, so this side is 1, and this side is, so 1 square is 1, and this is 1, 2, 3, 4, 5, 6, 7. 7 with square will give you 49, and you add, you take the square, so it will be square root of 50. Okay, see that? And this side, okay, you got 1, and you got 2, 4, 6, 7, so you get 49. So again, this one you're going to get square root of 50. Okay, see that? Now this side, you got 1, 2, 3, 4, 5, 6, 7, 8. You square that, 8 is 64, and it's 64. So you add, you get, and you have to take the square root, right? So it'd be 128. Okay? Okay, so now we can answer question. Okay? So A is the isosceles, yes, because both of, you don't have to simplify because this is not your final answer, right? You only have to simplify if it's final answer. So you can just leave it like that. You just want to see if the isosceles. So yes, because these two sides are same. So yes, it's isosceles. Okay, now to part B, is a right triangle? Well, you can see that it's not because answer is not because square root of 50 plus square root of 50 is equal to square root of 128. We have to square that, right? Okay, well, it's equal, right? If its Pythagorean is true, then it's a right triangle, right? So you got 50 plus 50 is equal to 128. Answer is no. Okay, it's not a right triangle. Okay, so again, a squared plus b squared equal to c squared, then it's a right triangle. If it's not equal, then it's not a right triangle. Okay, so that's it. Okay, now let's go to number 29. Again, you got 3 points. It says use the distance formula to determine whether the given points are collinear. It's a hint. Find the distance between each pair of points. If this distance is the sum of the other two, the 3 points are collinear. Okay, so we're going to do just like before. Okay, so let's go and sketch it out and make things a lot easier. Okay, so the first point, I'm just going to call it point A. So A is 1, 2. And 7, 4. So this is A. 7, 4. So 1, 2, 3, 4, 5, 6, 7, 2, 4. Okay. And negative 2, 1. So negative 2, 1. Okay, call it C. Now, if you draw it out right away, you know that this from this is so obvious. Okay, that wait, double check. Okay, 1, 2, and 7, 4. Missed by 1. Okay. Okay. And so by looking at these, right, again, there's easy way to do this, okay? You can do it by distance or you can do it by slope. Okay, notice the slope, if you go 3 over up 1, see, you go 3, 1, over here you go 3, 1, 3, 1, see that? So you can see that the answer is yes, okay? So this is, so answer is yes, okay, if you do it by slope. But they ask you to do it by distance, okay, to do the distance, okay, this is 3, this is 1, so this will be square root of 10, right? And from here to here, this is 6 and this is 1, so 6 squared is 36, right? And so this would be square root of 37, right? 2, so it would be 40. 2 squared is 40 other square, so it would be 40, okay? Then you do the distance of this whole thing, right? So from here to here is 9, so that's 9, so you square that, you go to 81, and this is 3, so square equal to 9, so total equal to 90, okay? So equal to square of 90, okay? Now you have to see if they're equal, okay? Okay, so again, to do it by distance, you have to see if square root of 10 plus square root of 40 is equal to square root of 90. At first it doesn't look equal, but you have to simplify, okay? So square root of 10 plus 2 square root of 10, and this equal to 3 square root of 10, right? You have to simplify using the square root, right? Like 40 divided by 2, you get 20, divided by 2, you get 10, right? So that's how you get that. Same thing with 90, right? Divided by 3, divided by 3, right? This comes out, right? So you can see that, yes, they're equal, okay? You can see this, yes. So you can do it by distance or you can do it by slope, okay? Again, when you sketch it out, make things a lot easier. Okay, if you just do it strictly by formulas and or by all that, you have to go through all this big mess. See that you have to do all these if you do it by formula. Okay, but if you sketch it out, it makes things much quicker. Okay, so number 31. Okay, you have -5, -2, and you have -2, +1, and you got 1, 3. Okay. By just sketching out, you can see right number 31 is going to be no. Okay. Again, if you do it by slope, this is 3, this is 3, right? If you do it by slope, this is 3, this is 2. Okay, so you can see it's not, right? And if you do it by Pythagorean theorem, okay, so a squared equal to 9, and so 3 squared is 9, 2 squared equal to 4, so this would be square root of 13, right? A squared plus b squared, you take the square root, right? So again, you square that, you add, and you take the square root. This one, again, if you use your special triangle, that's your 45 special triangle. So this is square root 3 square root of 2, right? Now to find this distance, again, right away you can see that it's not going to be equal, right? Because for this one, your triangle is this over here, so it'd be 1, 2, 3, 4, 5. So 5 squared equal to 25. And over here, 1, 2, 3, 4, 5, 6. So 6 squared equal to 36. And when you add this together and you take the square root, this would be square root of 71. And again, this is not going to equal. So this plus this does not equal to that. Okay. So again, this plus this does not equal to that. If they are equal, like this one over here, then it's yes. So you can see it's no. Okay. So again, if you sketch it out, it makes things much easier and quicker.